Hello, my name is Justin Ferralis, and today I'll be doing problem 4.57. So it says that a stuntman drives at a speed of 20 meters per second off a 30-meter high cliff, and the road leading to the cliff is inclined upward at an angle of 20 degrees. And it's two-part question. So, how far from the base of the cliff does the car land, and what is the car's impact speed? So, first thing you need to do is draw a diagram to show, you know, to, to illustrate what the problem is trying to say. So since it's inclined upward, we need a tilted axis. Then I'm gonna just draw it sideways. Okay. So it says that it drives at a speed of 20 meters per second off. So then your velocity just be going that way, and then the hill is 30 meters high. So 30 meters, and and it's at an angle of 20 degrees. Yeah. And then so the car is just gonna keep going like this. Then eventually it's gonna hit the ground. So that's gonna be 0 meters here. And then now we can write our givens. So we know that our starting position at the x point is gonna be 0. Um, it our initial starting point is gonna be at our initial starting point is gonna be at 30 meters high for the y component. And our x final is what we're looking for in the first part because it says how far from the base, so then put a question mark here. And our y final is going to be 0 meters because it's going to end up hitting the ground. And so we know for acceleration for the x component is going to be 0 just because it's moving at a constant rate. And our acceleration for the y component is going to be gravity. So gravity, which is also known as negative 9.8 meters per second squared. And so since we know our velocity, we can write down the components for it. So our v initial x would just be v initial cosine theta because it's at an angle. And same thing for VIY. So VI sine. So you would use the kinematic equation to solve this. So then it'll be, so the first thing you would solve for is the y. So you solve for the y first to get the quadratic equation, or quadratic equation. So you can use the quadratic formula to find the time, which is what we need to find out how far the car will land. So then it would be yf minus y initial equal v initial y time final minus time initial plus 1/2 a y tf minus t initial squared. So all the t initials are just 0 because that's where you start off at. So then simplified it would just be yf minus y initial equals tf plus 1/2 ay tf squared. And then you just plug in our givens. So your y final is going to be 0. Your y initial is going to be 30 meters. VIY is going to be VI sine theta, which ends up being so your beginning, so it's 20 meters per second, so 20 meters times sine theta, which is sine 20, so 20 sine 20. And the t final at the end of that. Plus 1/2. And then the acceleration for the y component is going to be gravity, so negative 9.8, and then t final squared. So 20 sine 20 ends up being 6.840 TF. This ends up being the 9.8 over 2 ends up being minus 4.9 TF squared, and it equals negative 30. So you can rearrange this so it can look like a quadratic equation. So you'll get 4.9 TF squared minus 6.840 time final minus 30 equals 0. So here we'd use a quadratic equation or formula, negative b plus minus b squared minus 4ac over 2a. So here is going to be your a, here's going to be your b, and here's going to be your c. So then you end up getting, positive 6.840 because it's negative here, but then it turns positive, plus minus b squared, so negative 6.840 squared, plus 4, and then your a is 4.9, and your c is going to be negative 30. I'm just right up here, negative 30. And all over 2 times 4.9. So you end up getting two answers. You end up getting 3.268367 and negative 1.872. And since you can't have negative sign, you'll just be working with this one here. Okay. So after that, you can plug this into your X final to like a X focused kinematic equation. So you will get X final minus X initial equal V initial X T final minus. So basically the same thing that we did for Y, we're going to do it for X, and this is to find the final position. Okay, so like I stated earlier, AX is the acceleration X component is going to be 0, so this is going to go to 0 here. Okay, so then that means this whole thing goes to 0 also. X final, your X final is going to be what you're looking for. X initial 0, so it's really just X final equal to V X TF, and then T initial 0 because that's just you start at 0. The time starts at 0. So then your VIX, or the X component for the velocity initial, is going to be VI cosine theta. So it was moving at 20 meters per second. And then it's, I think it's cosine. Yeah, cosine theta. So cosine 20. Cosine 20 times TF. Times TF. So our TF is right here, the 3.268367. So it would be X final equals 20 cosine 20 equals 18.79. And then your T final is going to equal 3.268367. And your final answer is going to end up being 61.42 meters. And now for the second part, it says, what is the car's impact speed? So what we're looking for is the final velocity. And since you're going to have an X and a Y, you have to use the component method at the end. So to find the X, or to find a final velocity for the X, the initial velocity in the X direction equals the final velocity in the X direction. So that means that your V initial X equals your V final X, and then your V initial X equals 20 cosine 20, which is up here, and that's 18.79. So that's going to be our VIX, or your V final component. So 18.79 meters per second. And then finally you have to solve for the VY final. So here you would use another kinematic equation. So let's go here. So V final Y equals V initial Y plus acceleration delta T. So V initial Y, as stated above, is going to be 20 sine 20 plus the acceleration, which was I stated earlier was going to be the gravity, so negative 9.8, and then the time, which is up here again, 3.268367. So your VIY, or yeah, so your final velocity for the y is going to be 6.840 minus 32.02997. So it ends up just being negative 25.19 meters per second. So with these two numbers right here, you can't even see that. Okay. Well, for these two numbers right here, you would have to use the component method. So your final velocity equals the square root of the x component squared plus the square root of the y component squared. Is that right? Oh yeah, y. Oh jeez. Okay. So that equals 18.79 squared plus negative 25.19 squared. And your impact velocity, is it impact velocity? Oh, your impact speed is going to be 31.43 meters per second. And yeah, that is how you do problem 4.75.